Okay, turn to your table buddy and ask them what they think. Ready, set, go.
Like I never left. So if I have diabetes, because my fingers and hands are all, or my fingers and feet are all
like
so
circulation?
cold.
Like,
Yeah.
would you have bad circulation?
I don't know.
Oh, okay.
Are you dry?
I'm not positive.
Probably because you have bad circulation.
There's a lot of other bigger symptoms you'd see. Does your grandpa have type 1 or type 2? You don't know. Okay, so he has type 1. So yeah, there's a lot. It is, I know there is some connection to it with diabetes.
And you're always thirsty.
That's, yeah. But even some bigger ones. But that can be. But I know there's a lot of people who also just have bad circulation. And it's normally that. But if it runs in your family, maybe. It is a weird one how it can just pop up, like you may not act, and then it can just like activate it.
Are we turning in our notes from term 1?
Yeah. Just hang on. Yes, keep them.
No.
Okay. Here we go, everybody. Eyes up front.
Bro, you definitely have diabetes. I can just feel your
Right.
giving up diabetes.
All the different bonds, get it?
My dad would have loved it.
So slow.
That keeps happening on my classes.
Really?
It's the internet. My teachers are getting so mad about it.
Drives me crazy. I gotta have time to just wait for the slide to change. Okay, this is slowly coming up here, friends. So, chemical reactivity and a chemical bond, everybody, okay, is when two atoms do something with their electrons, we'll talk about the different ways, to become a molecule or compound. Okay, so there's some sort of attractive force holding them together, and it makes something new. Chemistry is so weird because as like symbols, it doesn't look like that big a difference. Okay, for example, I have Na as an element, that's sodium. We saw sodium metal, does anyone remember what it looked like? We dropped it in water. Right, so it exploded in water, it was gray, they were soft metals, right? Okay, chlorine, we'll talk about why there's a 2 there later. Okay, chlorine as an element is a yellow gas, extremely toxic. Okay, yeah, it's like a gas that has a yellow color to it. So you'd actually be able to like see it in the air. Okay, so this is extremely dangerous, explodes in water. This would kill you if you inhale it. But if these two things stack together, so I imagine them like Legos, right? Separate Legos, crazy dangerous. when they come together and make NaCl, anyone know what NaCl is, Jackson? Yeah, it's table salt, which is a necessity for life, right? Like you need a certain amount of salt in your diet. It's very important for us, right? So it's so crazy because as separate things, but then when they come together, it's crazy how it changes. Okay? Yes, Boston.
If chlorine is like not good, why do we put it in our pools?
Good question. So a lot of times when we talk about substances in something, right, like chlorine in our pool, or we mentioned, like, remember we said there's potassium in a banana, but it's not the straight up potassium metal, right? It's a potassium compound, so often it's like KCl. So it's the same thing with chlorine in pools, is it's not actually just pure individual chlorine, it's a chlorine compound. Does that make sense? Yeah, great question. Have a smiley face. Write it down somewhere else because I forgot to print our new trackers for the term. So any smiley faces earned today, just put them in your notes and then you can pass it over. Okay? But the idea is everybody, all right, we got to stop this side talking. We got lots to do. Okay? Is when things become a compound, okay, atom, compound, or molecule, you can use either term, okay, their properties are completely different. Hi, Nathan, here, take one of these. Yeah, you're back there. Okay? So, when things combine, physical properties, chemical properties, how it looks, how it behaves has changed due to the fact of often stability. That the thing it's become becomes more stable than the pieces it was. Okay? So, the different ways that this happens is it's all about valence electrons. Okay, core electrons, they don't matter at all. Okay, core electrons, they just stay inside. Valence electrons are the ones that are changing. So remember our trend for valence. We count 1, 2, skip, 3, 4, 5, 6, 7, 8. And the goal, and I put quotations because it's not a like solid goal, but it's a rough goal, is they all want 8 valence electrons. Once they get 8, they achieve this type of stability. So that's why they bond, that's why they change. That's why the things in column 8 don't bond. Neon always exists as just neon. There's no neon compound ever. It doesn't exist. Same thing with helium. Helium never exists with anything but itself. Okay? We mentioned last time how the way they can change their electrons sometimes is by losing electrons. Okay? Oh man, this is going to take forever. Come on, click. Okay, so one way they can do it is by gaining electrons. So if I'm oxygen, how many valence electrons does oxygen have? 6. So if I'm oxygen, I could gain 2 more and be stable, and I'd have 8. Okay? They also can do this by losing electrons. Okay? How do you get full by losing? How does that work?
Too many?
What do you mean by that, Caitlin?
Like, you can't be stable if you have too many, so you have to get rid of them, right?
Good. The idea is the shell underneath is going to be full. So if I'm sodium and I have 1 valence electron, rather than gaining 7 more, if I just lose the one I have, the shell underneath is full. So they either fill their shell or empty it, or the last way is sometimes they just share. And they don't give it or take it, they just share between them, but by sharing, it adds to their valence shell. Okay, so these are the different types of bonds that happen. Okay, so in an ionic bond happens when the electrons are transferred. One of them gives, the other one takes. Okay? This is what's going to happen whenever you have a metal combining with a non-metal. So, Na is a metal, Cl is a non-metal, so NaCl is an ionic bond. Okay? Covalent is a sharing of electrons, but we're going to put it as share 1 to 1. Okay, I'm going to share one with you, you share one with me. That is going to increase our valence electrons because we're sharing them between us. Yeah?
So how's that not transferring? How are those two different?
Let me draw a picture, maybe this will help. So in this one, so NA's has 1 dot, chlorine has 7, so their dots are like their valence electrons, okay? Sodium says here, take my 1, because now I'm empty, which means I have a full other shell, right? And then chlorine now has 8, so they both get what they want.
Okay.
In a covalent, let's see, let's do chlorine and chlorine. Okay, so they both come with 7, so they both need 1 more. So what they do is they do this thing of like, okay, I'm going to share 1 with you, you share 1 with me, and these 2 dots belong, like it counts for both, so now they both have 8. Does that make sense?
Yeah,
a
it
little
does.
bit more. Yeah, good question, Kate. That was my piece for that. Okay. This type of bond happens between nonmetals. Because nonmetals already have a lot, so they don't want to give up what they have, so instead they just say, let's share with each other so we can add up to 8. Now our last one by name is probably the easiest. What type of things would form a metallic bond? Yeah, so metals with metals. So when you have a metal bonded with a metal, it's called a metallic bond. Okay? And this one's kind of an interesting idea. And once again, we'll dive more into these next time when we get, next time we'll focus very heavily on the molecular side, like what's going on at that molecular level. But this one is share with everybody. Okay, so it's a type of shared relationship, but it's going to share with everybody. Okay, so imagine if we were all a metal, let's say sodium again. How many valence does sodium come with? 1. Okay, there's no way if we all have 1 that we can like just share with 1 person and get up to 8. So what we do is we all take our 1, and then we're going to pass them around to everybody. And if we pass fast enough, it'll make us all feel like we have 8. That's how metal works. They really don't all have 8 individually, but because it's being passed so much, it gives the feeling of having a full shell. Okay? Yeah?
Where do metalloids come into the
Oh, good question. For the most part, we can kind of ignore them because they're kind of weird.
Okay.
When it comes to it, in terms of bonding behavior, I would treat metalloids like a non-metal.
Okay.
Yeah, good question though.
Can you show us some, can you draw a picture of like how to share metallic works? Or is that
Let me
easier
think.
than not?
It's a big shot now. So let's do, if we have gold here. So here's like a gold atom. Okay? Like a bunch of gold atoms. Okay? They all have 1 electron. And then those 1 electrons just get passed everywhere. It's often nicknamed a sea of electrons is how they, a metallic bond. So yeah, good question, Sasha. That was my piece of that. Okay. All right, let's do these ones together, and then I'll have you try the other ones for some smileys. Okay, so this is our first I can. Is if I give you a formula, you should be able to tell me, oh, that is ionic, or that is covalent, or that is metallic. Okay, so what we're going to do, I'm going to draw a rough periodic table here. Okay, dividing line is this staircase, right? Okay, everything over here is a metal except for, who's the imposter? Yes, right, hydrogen is part of the nonmetals. Okay? All right, eyes up here, everybody. So I'm going to find magnesium on the periodic table, which is about here. I'm going to find chlorine on the periodic table, which is over here. So since I have 1 on each side of the diagonal, that's going to make it ionic. I don't know if it helps, but ionic, one of my students said, oh, ionic is ironic, because it's like a mixture of 2 things. Kind of rhymes, kind of makes sense. Not if you ask an English teacher. Okay, questions how I did number 1? Did it matter everybody that there was a little 2 there? Nope. The numbers of things doesn't matter. It's just what are the pieces. Okay? All right, zinc.
That one gonna be metallic.
Good. So in a sense, we're saying zinc bonded with more zinc. Right? So that's going to be a metallic bond. If it only gives you one symbol, it's just referencing it to itself. Okay? Last one here. Hydrogen, is it a metal or non-metal? That's our non-metal. Phosphorus is a non-metal. And oxygen is a non-metal. So if it's only non-metals, that would be covalent. Oh, I put an extra L in there. Okay. Questions before you try those 3? All right. 60 seconds. Smiley face up for grab. Ready, set, go. I guess 3 smiley faces up for grabs. Oh yeah, that might take the longest part is finding them on the table. Yes, boss. Yeah, go real quick. You're done? Number 72.
¿Lo voy a tarea? No escuché. ¿Qué hueá son dos? Como que se oye. Se lo mete con esa. Por eso.
Once you're done, compare with your table and see if they agree with you.
So, I got metal, I already did.
Nice double. Here, nothing. Take one of these.
Las dos son una la mierda de la otra.
Oh. Yeah, this one. That should be turned too.
No, I like the Christmas one.
You want to keep Christmas all year?
Oh, where?
No, it's literally Christmas season. I mean, last year wasn't even
Literally not, it's October.
No, I should have done it.
seasonal. Here's the issue. We
Entonces
pushed
la Nike
it
de
to
que
end right before Christmas, so then it would be weird if we did it after. So let's just stick with this one.
Let's give it a feel. We'll feel it out. Okay. Everyone, this is a C in sign language.
No quiero cortar, pero no sé.
Which
Okay.
hand?
Okay, this is an
Oh,
M.
it's not. This one's a backwards.
Okay, and this is an I.
See?
It's like 3 bumps. Okay? Alright, I'm going to point to it. You're going to show me a sign of what you put. Ready? 3,
Oh, okay.
Wait, well, I and
I
then
would fail.
metallic?
N. Yep. Okay. 3, 2, 1. This is. Show me. Don't say it.
Oh crap! I forgot to do it. And don't say it. Sorry.
Good. If you're showing me an M, have a smiley face. You're correct. It is metallic. Okay, everyone ready? Number 2, 3, 2, 1. This is. Don't say it. Just show it. Oh. And if you can't remember the sign, make up something that looks like the letters. Good. It is ionic. Good job. Have a smiley face. And 1, 2, 3. 3 is. Good. Good job. Okay. So have a smiley face for each one you got right, which is everybody. Okay. All right. Now, what we're going to be doing is we're going to go into the lab, and we're going to be looking at 2 ionic substances, 2 covalent substances, and 2 metallic substances. The goal now is to start making a connection between that type of bond and some properties that they have. These are the 4 properties we're going to be investigating. Okay? I gave you their definitions. Let's fill those in here. So malleability is the ability of something to be shaped without breaking. Okay? The ability of something to be shaped without breaking. Okay? We're going to come back. Well, actually, we'll hit the molecular level. The test you'll do in the lab, everybody, Reese, can you put that away, please? Is we're going to be hitting these substances with a hammer. If they are malleable, then they will just flatten, but stay intact. If they're not malleable, then they would shatter. Okay? Okay, so that's how we're going to test malleability. Okay, obviously some things would be malleable if you can bend with your hands. Okay, like clay is very malleable, but some things you might need a little bit more force, which is why we'll use a hammer. Okay, what this means at the molecular level is if something can bend without breaking, box going, oh, there we go. Okay, then something must be holding the atoms together as they shift.
Are we supposed to write that whole?
You can summarize it. Okay, yeah, they didn't make that box very big, did they?
Yeah, I was gonna say I don't know that.
Okay, you could put atoms must be held together as they shift. You can kind of take the second half of that sentence.
Say that again? Atoms must be held together as they shift.
Yeah. Right? If something doesn't shatter, then that means even if I move them from here to here, there's something still holding them together. Okay, otherwise, if they move from here to here and they just shatter, then there was something else that was causing that. Okay? All right. Yeah, I'll get the second one. Everyone got malleability?
Yes, ma'am.
Okay, all right, the second test, or another test, I should say second because we're going to do these in any order, okay, is solid conductivity. The test for solid conductivity, everyone look up here, you'll be using a conductivity probe, is what it's called, okay? On the back of it is a little code of what it means if you forget, okay? First off, no, you will not get electrocuted if you touch it, in case you were wondering, okay? Also, there is an on-off switch, so before you tell me it's broken, make sure you turn it on. I would, though, because the batteries can eventually run out, before you start testing your substances, I would test your conductivity here by putting it on the sink in the lab. Oh, maybe this one is dead. I picked a great example. Oh, no. So if it works, you can see that. I don't know if some of you can see that light. Oh, I know this will work better. The trick with using these is you have to make sure both prongs are touching the substance. Otherwise, it will give you a false reading. Okay, so if I put it here and making sure it's touched to the aluminum, then it should light up. If it doesn't light up, then it's not conductive as a solid. Okay, that means electricity could run through this thing.
So,
Okay.
why is there a red and green? So red and non, or is it
It's like levels of conductivity. If any light comes on, it's conductive. But like if both come on, then it's technically high. If only one does, it's like medium. But yeah, good question. Okay? All right, here's what I want you to put here. Okay? Let's simplify this. Electricity is simply moving electrons. So if something can conduct electricity, then it's keeping the electrons moving. So just write that in that second box. Keeps the electrons moving.
Oh, I wrote what first
Okay. Keep the electrons moving. Okay. I'll underline it here. Just write that. Okay. If something can conduct, it's because when I pass the electrons to it, they can keep them moving. If it doesn't conduct, then the electrons get stopped. Okay? All right, solubility is the ability to dissolve in water. Okay? For our solubility test, you'll have what's called a well plate at your station. Okay? You'll then have your 6 samples we're testing, and you'll have tweezers to pick up some, because some of them are like big chunks. And then you'll have the tiniest little spoon you've ever seen, okay, to scoop up the rest. The trick with solubility, everybody. That's it.
Okay, you said on.
The trick with solubility
I was making.
is you don't want to add too much of your sample, because you can once again get the wrong idea. Okay, if you add a whole huge scoop of your substance, it's probably not going to dissolve just because you added too much. That's why we're using this, is to make sure you only add a small amount. Okay, so you'll add just a scoopful into it. You'll then have a little squirter of distilled water, pour it in there. You can give it a little stir. If it dissolves, meaning you can't see it anymore, then it's soluble. If you can still see it, then it's not soluble. Okay, questions on solubility? At the molecular level, put water must interact with it. Okay, if it's dissolving, it's because there's some sort of interaction with the substance. water and the substance are somehow interacting, causing it to dissolve. If it doesn't dissolve, then that means there's no interaction. Yeah, Austin?
Not like sodium where it explodes on contact.
Yes. So that would be more reacting with water, right? Versus just dissolving in the water.
No, pero hace el libro, me dice también.
Okay, everyone okay on that one? Okay, our last test we're gonna do is melting. Okay, so which is the ability of a substance to turn from a solid to a liquid by heating. Okay. We're not gonna put them in fire, we're just gonna put them on a hot plate. Okay.
We're gonna do like chocolate, do like milk.
Not quite chocolate, but.
Okay. El primero y el de arriba fueron mucho más caros.
At the melting point station, everyone give me your eyes this way. Okay, you're gonna make a little melting dish. So here's an example one. It doesn't need to be very big. Okay, because you're just gonna put a very small amount. You have the same tiny spoons here on this. Okay, so you're gonna have one dish, and then you'll kind of just put all 6 of it, just spread them out from each other on the dish. Just make sure you know which one is which. Okay, you'll then very carefully carry this over to the fume hood because we have to melt in there. Okay, I'm already going to have them on, so be aware that it's already going to be hot. That way you don't have to wait for it to heat up. Okay, you'll set this on here, but as soon as you set it, someone needs to start the timer. There's some timers on the fume hood. They're magnetic. Just grab one and use it. Okay, what you're going to record is the time that they melt, if they do. Some of these substances, our hot plates do not get hot enough. Okay, your oven would not get hot enough to melt these things. They melt at, we're using the term high, but you need to recognize like what that means. Okay, like it is an extremely high temperature, so they will not melt on these. Okay, after 2 minutes have passed, then you can just stop because once again, those that will melt will have, and those that won't will never melt, so don't just keep waiting. Okay, so after 2 minutes, there's a little waste bin and some little tongs. So you can grab this and throw it in the waste bin. Okay? All right. At the molecular level, what's going on with melting, okay, is, let's just do this, is something, if it melts, then there's something about the bond being weak. Okay? Bonds are pretty weak if it melts or something like that. Did I see a hand in the back?
I was just gonna, with the melting one, do we like record the time when it's fully melted?
Yeah. And it will probably, because you're only using that tiny spoonful, so it probably will go pretty, but yeah, not when you start, when it's like the whole substance is melted. Yeah, good clarification for that. Okay. Any other questions on that? All right, let me hand out your lab, your homework packet, and we'll talk about the lab. Everyone is going to be, you'll be working with a partner today, so not in a group of 4. So let's find, oh, this actually works. Maddie, will you have me Preston's partner?